So how to find out the Young modulus in this case? The Young modulus can be find out, as you know, the basic concept of that it is equals to the ratio of stress upon strain, right? So in that case, according to the graphical relationship, you just find out and you just assume any of the values. Suppose the value corresponding to 0.001 or the value corresponding to 0.002. For a particular stress, whatever the strain is produced, you can assume any of the values. You will get the same answer here. Now if I just plot that one, that I am getting according to my graph, that it is approximately 200. Now there is a strain of 0.001, and for that case I'm just getting the stress as 100 into 10 to the power 6, right, in this case. So what can I write it down here? That the Young modulus, that should be equals to what the stress I am just getting corresponding to 0.001, that is of 100 into 10 to the power of 6 divided by what the strain, that is of 0.001, right? So finally what I am getting, the expression can be modified as 10 to the power 8 divided by, that is of 10 to the power minus 3, right? So it should be 10 to the power 11, that one, 10 to the power 11 Newton per meter square. Is that simple, right? So whether the solution is understandable, everyone?
Yes, sir.
Okay, that's good. Now it's one of the easiest problem. Now if the question asks you that find out the approximate yield strength of this material, how to find out the yield strength of this material? What I mean by the yield strength of a material? What do you mean by that? Yield strength of a material? It is actually the stress you are applying on that material. Yield strength is the stress you are applying on that material. So in that case, what is the maximum value of stress you are applying on that material? What is the maximum value of stress you are applying? Just see the graph and give me the answer. What is the peak point of the stress? As I can see in this graph, the peak point is about 300 na. So in this case, whatever the maximum stress you are applying, that is actually the yield strength. So let me write it down. The yield strength, that is of the stress you are applying, maximum value of the stress you are applying on that material, that is of 300 into 10 to the power of 6 Newton meter inverse of 2, right? So you can write it down it as well as 3 into 10 to the power of 8 Newton meter inverse of 2, right? So this is actually the yield strength, or this is actually the stress you are just applying on a material, and the graph can be plotted. It's a one type of linear graph up to the peak point, right? That means the stress is applied to the material that is directly proportional to the strain. So in this way the answer can be given for that. So I'm just moving to the next question. Okay, now the next question is about, I'm just drawing a figure, just draw it with me. Now there are the two weights. One is having a mass of 4 kg and one is having a mass of 8 kg. The length that is of 1.8 meter. Okay, this is a steel wire, and this is of 1 meter. This is a brass wire. Okay, so in this case the two wires having the diameter, the same diameter they both have. The diameter is about 0.25 centimeter. Okay, now in this case what is given in the question, that there are the two weights. which having the mass as 4 kg and 8 kg. They both are tied up with two different materials, string. One is made up of steel, another is made up of brass. The steel wire is having the length of 1.8 meter and the brass wire is having the length of 1 meter, right? In this case, the rest of the things are given like that if the masses are tied up with that of string, there would be some extension. That means there will be some elongation can also be seen from there. Okay, so let me give you that. What is the elongation that is produced by that? In this case, you just have to find out the elongation, that is as delta L1 for the case of steel wire, and you have to find out the delta L2 for the case of brush wire. Okay, for that case, what the things you needed, that is given over here. Just try to find it out. Now in this case, if I just going to help you out, now that should be uh, in this case the young modulus for both of the wires. Let me give you the hint that it can be found in a better way, right? The young modulus of the wires, that is not given in the question. Now let me give you out, otherwise you guys will not able to calculate that one, right? Now the young modulus of the two wires, that is of young modulus of steel, that is of 2 into 10 to the power of 11, and young modulus of brush, that is of 0.9 into 10 to the power 11. That's all. That involves a huge calculation, as I can see that the values given that are not so much of comfortable here. Even the diameter is given is in centimeter. Now, so let me help you out. For both of the wires, the cross-sectional area will be same. So at first what we should find out? We should find out the cross-sectional area, right? The cross-sectional area should be pi d square by 4. Pi d square by 4, that means of pi by 4 into, what is the value of d? That is of 0.25 centimeter. That means I can write it down as 0.25 into 10 to the power of minus 2 meter. Remember, this is the CBSE unit and you have to convert it to SI. So that is of 0.25 into 10 to the power of minus 2, that whole square, right? So the area is found. So what the required formula to find out the delta 1 and delta L1 and delta L2? That is actually the expansion in the string. That what is the expansion in the case of steel wire and what is the expansion in the case of a brush wire? So that is of delta L1 we have to find out, right? So what is the formula for young modulus? That is the force by area divided by what is the expansion that happens and what its original length, right? So this is the first case of steel wire. Let's suppose this is a y1, that is equals to f1 by a delta L1, and this is of L1. Why I have not given the area as a1? Because the area is same for both of the wires as the diameter is same. Now in this case, it can be simplified as f into L1 divided by a into delta L1. Sorry, just move to the next slide. Now I hope the screen is visible for everyone. It just comes back. Now that portion, in this case, if that portion that is equals to y1, what the value of delta 1 here? Delta 1 that is equals to f, sorry, it should be f1, f1 multiplied by L1 divided by a multiplied by y1. That kind of expression we'll get for, that's delta 1. Sorry. Now I hope the expression is visible for everyone. In this case, we have to find out this delta L1. And for the calculation of delta L1, we have just found that equation that it should be like that. I have just arranged it, nothing else. Up to that portion, is there any doubt? how I have found that expression? That kind of doubt is there? Everyone, girls and boys, just give me a reply quick fast. Up to that portion, is there any doubt? Whatever the things are given. In this case, there is a steel wire, and with that, okay, there is a steel wire, and with that steel wire, one weight is suspended, and there is a brush wire, and with respect to that brush wire, another weight is suspended. Diameter for both of the wires is same. In this case, we have to find out delta L1 and delta L2. Okay, let me change the ink. I think it is very boring now. In this case, you have to find out these two, only delta L1 and delta L2. We have the Young modulus as, this is Young modulus for steel, that is of Ys, and this is of Young modulus for brush, that is of Yb, right? So in this case, we have find out the area. The area is like that, that is a pi by 4, 0.25 into 10 to the power minus 2, that whole square. And in this case, we have find out the Young modulus, that is equals to force upon area divided by the elongation upon its original length. So we have just, if you have any kind of doubt, I think, let me explain you in that way. Now Young modulus, that is a force upon area divided by delta L by L, right? That kind of thing I have just written, and then I have written it that's like that. This is actually F by A divided by delta L1 by L1. Now when that divided sign become into sign, it is becoming L1 by delta L1, right? Now I hope it is clear that it is F1 L1 divided by A into delta L1. Now in this way I am getting the expression. Now if I cross, I need the value of delta L1. So I am interchanging the position of Y1 and delta L1. After interchanging their places, delta L1, that is equals to F1 L1 divided by A into Y1. That's all. Simple. Whether you are getting the concept how we have derived the equation, finally we are
Yes, sir.
going to use that expression, that is of delta L1 equals to F1 L1 by A into Y1. I hope maximum of the students are feared after watching that equation. Lot of ones are there. Why I have written that ones? Because there are two wires. One is of steel, another is of copper. If I write down simple y equals to F by A divided by delta L by L, that will be confusing for the examiner to decide which one is for steel and which one is for copper. Sorry, brush. That's why I have just written that one over here. But that's so easy. There's a simple mathematical calculation. So in the case of that, I have to substitute all of the values in that given expression. This is our required expression and I need to find out all of the values. Now what is the force? What is the value of F1? For the case of steel wire, what is the value of F1? I'm talking about the steel wire. With respect to that of steel wire, brush, actually the brush wire and the weight is suspended. Now in that case, whatever the force you need to expand it, when you are expanding that steel wire, that means brush wire is helping you also. The weight of the steel wire and the weight of, sorry, the weight suspended with the steel wire and the weight suspended with the brush wire, they both are helping you out, right? So in this case, what will be the value of the force? That is equals to 4 plus of 8, that is equals to 12 kg, right? I can, it is actually the force, it is actually the mass. Now it should be multiplied with 9.8 to get the force as in Newton. So in this case, F1, that is equals to 4 plus of 8, that is of 12 kg. You just omit that kg word because in this case you just have to multiply that 12 with 9.8. So F1 will be equals to 12 into 9.8. In this case, what is the value of L1? That is of 1.8 meter, that is given. In this case, the area is given as pi by 4 into 0.25 into 10 to the power of minus 2, that whole square. And the value of y1, that is of, what is the value of y1? That is of 2 into 10 to the power 11, right? That is of 2 into 10 to the power 11 Newton meter inverse 2. I have to substitute all of the values over here, right? So this is not a very tough question. That kind of question can be asked in your exam. So be prepared for that. Just think about that who had made that question. If he can make the question, why you guys cannot solve it? So it is so much of easy and you guys have to solve. The simple easiest question of that elasticity. Now there are lots of chapters are there. That is of in the chapter of thermodynamics, in the chapter of fluid mechanics, lot of toughest concepts are there. So that you guys have to be prepared. Okay, lots of typical calculations you have to just keep in mind. So that's why I'm just telling you out. Now soon you guys all you will have a good news. You all will have a very good news on behalf of me. Just wait for that. Within 7 days or within 10 days, I think you will have that good news. Now that is of delta L1, that is of F1 multiplied by L1 divided by A into Y1. If I substitute all of the values, what the thing that I will get, that is of 12 into 9.8, that is of force, multiplied by L1, that is of 1.8, divided by area, that is of pi by 4 into 0.25 into 10 to the power minus 2, that whole square, multiplied by Young modulus, that is of 2 into 10 to the power 11. Simple. You just calculate in this. I have just substituted all of the values and you just calculate this expression, you will get that answer. This is for the case of delta L1. Okay, now after that I hope that portion is not understandable for everyone. Whether it is like that, it is not understandable, or something is understandable.
Understandable.
Okay, okay, that's good. Now in this case you just have to calculate. Don't use the calculator. Try to minimize the equation as much you can in this case. So the value of delta L1 you can calculate from this expression. The value of, whether you want to write down, you can write it down as well. Though you get the notes of that also. If you want to write down that expression, you can. Because in the next case, we are just going to find out that delta L2, right? That delta L2 we are just going to find out in this case. This is the actual diagram. Now, if we want to find out that delta L2, what will be the expression? If you want to expand that brush wire, that means you have to apply very small force, and that is only due to the weight of 8 kg. When we are going to find out that delta L2, that means a force can be applied to expand the brush wire. Now the force that is responsible to expand that brush wire, that is actually the weight of the brush wire will help you out in this case. Now if the weight of the brush wire will help out in this case, so that means the value of F2 can be found out. The value of F2, that is equals to 8 into 9.8. That's simple. That Newton. And the rest of the things you know. So I'm just moving out in finding out that delta L2. I hope the expression is written by everyone. Whether it is written?
Yes, sir.
Okay. Now for the expression of delta L2, what the thing that we can get here, that is of For the case of delta L2, that is a force multiplied by, you can find out the expression from Young modulus as well. But if I just directly write it down like that, that is of A into delta L2, that will not be understandable. Sorry, there is of Young modulus Y2. You can write it down the expression as well, that is of force F2 divided by of area divided by delta L2 upon L2. You just short it out, it will be F2 multiplied by L2 divided by area multiplied by delta L2, and that should be your Young modulus Y2. And if I want to find out the expression for delta L2, just interchange these two quantities. If these two quantities are interchanged, then delta L2, that will be equals to F2 into L2 divided by A into Y2. Now in this case, whatever I have just explained, that in this case, if you want to expand that brush wire, that the weight that will help you out, that is of 8 kg. Now in this case, the force that should be of 8 into 9.8, right? L2 is given as 1 meter. Area is given. You just have to find out that delta L2. Now I am just going to substitute all of the values over here. That will be 8 into 9.8. L2, that is of 1 meter. Area, that is of pi by 4 into 0.25 into 10 to the power of minus 2, that whole square, multiplied by the Young modulus, which is given as 0.9 into 10 to the power 11. Just try to make the solution and you will get the answer. Okay, now lots of complex questions are there. Don't give up at this point of time. If you just give up at this point of time, now rest of the question cannot be solved because they are more difficult. There are more calculations, more complex mathematics are there. But mathematics is not very much of complex. Just have to make it easy. That's all. So up to this point, whether the solution is understandable, how we have find out the solution for the case of steel wire and brush wire. Now this week,
Yes,
in
sir.
this week, today is Friday. That is of Saturday tomorrow. Tomorrow and the next 4 to 5 days, I am dedicating for the question solving only. There are no more lectures. Lot of lectures I have just given. Now we'll only solve lots of problems, lots of questions every day. Now let me move to the next question. You guys can make the solution of this question. Just simply find it out and don't use the calculator because at exam time you will not get that. That's right. Now, what is the next question? That is of, there is a word problem. There is a question number 3. A rigid bar of mass 15 kg is supported symmetrically by 3 wires of 2 meter long. Sorry, just move to the next slide. Now, those at each end are of copper and the middle one is of iron. Determine the ratio of the diameters. Determine the ratio of their diameters. A rigid bar of mass 15 kg is supported symmetrically by three wires of 2 meter long. Those at each end are of copper and the middle one is of iron. Determine the ratio of their diameters. In this case, some of the things are given. Young modulus for iron, that is of 19 into 10 to the power 10 Pascal, and young modulus for copper, that is of 12 into 10 to the power of 10 Pascal. These two things are given. Just try to find it out. Have you written that question?
Yes, sir.
Okay. So in this case, let me help you out. A rigid bar of mass 15 kg is supported symmetrically by three wires. Suppose this is the rigid bar. This is the rigid bar, and it is supported by three wires of 2 meter long. That means at each end are of copper wire. Suppose at each end are of copper wire. Suppose these are the copper wires. These are the copper wires, and the middle one is of iron wire, right? The middle one is of iron wire. Determine the ratio of the diameters. If I want to find out the ratio of the diameters, at first you have to find it out that what is the relation of their diameters with respect to their young modulus. Now young modulus, that is equals to F by A divided by of delta L by L. That formula we know, that is equals to F into L divided by A into delta L, right? Now what is the value of A if the diameter is given? That means area equals to pi d square by 4. That formula we know. Now if I substitute that value, in this case if I substitute that value, that F into L divided by, in the place of area, that will be pi d square by 4 multiplied by delta L. So in this case, what you have understood, what is the relation of that young modulus here? That the young modulus is inversely proportional with that of d square. If I write down the relation again, that I need the d square only because I need the ratio of their diameters with respect to their young modulus. And I can see if this is equals to y, that means y is inversely proportional with the d square. D square is in the denominator here. Now it is as simple as possible. In this case, as the young modulus, the relation between the young modulus and the diameter, as I have found here, that means I can find out the ratio as y1 by y2, that is equals to d2 square by of d1 square, right? I can find out the ratio as y1 by y2 equals to d2 square by d1 square because young modulus is inversely proportional with that of d square. Now in this case, d2 by of d1, that is equals to root over of y1 by y2, right? So what is the value of y1? In this case, y1 we are just assuming this is for, suppose whatever we have just assumed, this is for iron. You can at first derive just define one thing, that y1 is for young modulus of iron, y2 young modulus of what the next material is, copper, na? Young modulus of copper. What is d1 here? d1 is the diameter of iron and d2 is the diameter of copper. That the things need to be derived here. That means you are telling the examiner that these things I have just assumed in this way. So the Young modulus of iron, what is the Young modulus of iron? That is of 19 into 10 to the power 10 is just given. And what is the Young modulus of copper? That is of 12 into 10 to the power of 10. After substituting the values, 10 to the power 10 will be eliminated and it will be root over of 19 by 12, and that is of d2 by d1. So d2 by d1, that is of root over of 19 by 12. So d1 by d2, that is of root over of 12 by 19. So in this way you can find out the ratio of their diameters.